Welcome to another edition of Physics Videos. Our topic for today is how to calculate the work done when the volume of a system of gas molecules changes. To keep things simple, let's imagine that we have a quantity of gas inside a cylinder with a movable piston, so that the volume of the gas can change. It might look something like this. The blue area represents the system of gas molecules. The area of the piston in contact with the gas is A. The gas fills a length L in the cylinder when it is in equilibrium with its surroundings. In this case, equilibrium means that the pressure exerted from outside the cylinder on the piston is the same as the pressure exerted by the gas molecules inside the cylinder. Now let's add some thermal energy to the gas. The first thing that will happen is the kinetic energy of the molecules will begin to increase. This will cause more violent collisions between the gas molecules and the stationary piston. The molecules will begin to exert a larger force on the piston. The larger force produces an unbalanced situation, so the piston begins to move. As the piston moves, the pressure from inside decreases because the molecules don't collide with the piston as often. So, if we add the thermal energy slowly, we can have the gas volume expand at a constant pressure. During the time the gas is slowly expanding, the constant pressure moves the piston a distance x, as shown in the diagram. The constant pressure exerts a constant force. Recall that pressure is force per unit area. So force equals pressure times area. Also recall that the work done by a constant force to move an object a distance of x, is the product of F and x. Now, let's put it all together. If we combine the two equations we get, work equals P times A times x. Now, notice that A times x is the volume colored in orange in the diagram. The orange volume represents the amount by which the volume changed as a result of having the gas expand. To see how we handle things when the pressure does not remain constant requires some thought. We can produce a graph that shows the state of the system and how it is changed. This graph, known as a P-V diagram, shows the initial state of our gas. The gas is at a pressure, P, and occupies an initial volume of Vi. Now, let's let the gas expand to a final volume, Vf, while the pressure remains constant. This is what the graph will look like. What we need to notice is that the quantity we have defined as work, the product of P and delta V, is shown on this graph. The shaded area is the product of P and delta V. So, we can say that the work done to change the state of a system of gas molecules is the area under the P-V diagram. This result will be true, no matter what shape the change produces on the P-V diagram. We'll explore some interesting P-V diagrams in another physics video.
See you next time.